All right, so we've talked about how to prove trig identities, and today we're gonna look at two more examples that just to show you a different way of thinking and doing some of these proofs. Again, it's not, these proofs cannot be done by just one way. There are multiple ways that each question can be approached. So if you think of a different way of doing this question, doesn't make it wrong, right? As long as you're not basically breaking any math rules, essentially. Okay. So let's get question 15 and 17 from the worksheet that's assigned to you. So we have 1 plus 2 sine theta cos theta over sine theta plus cos theta equal to sine theta plus cos theta. We want to prove this. So as we said before, we make a left side and right side. So my left side is 1 plus 2 sine theta cos theta over sine theta plus cos theta. And my right side is just sine theta plus cos theta. Then we said that we're gonna work on a more complex side that we can actually do stuff. Like on the right hand side, there's only sine theta and cos theta. There is really nothing much I can do about it. But on the left hand side, you might look at it and say, well, there's really not much over there either, because you have 2 sine theta cos theta. There's no square for you to change. For example, for sine square, you can change it to 1 minus cos square. But there's nothing like that. And you want to end up with just sine theta plus cos theta. So just thinking backwards, if you have sine theta plus cos theta squared, then it would have canceled out with the denominator, and you would have ended up with sine theta plus cos theta. So how can you come up with that? Now, looking at your numerator, you see that you have 1 plus 2 sine theta cos theta. Now, that 1, what can you do with that? Correct. If you remember, we know that sine squared theta plus cos squared theta, that's equal to 1. So I just replace this 1 with sine squared theta plus cos squared theta. And there's still plus 2 sine theta cos theta over sine theta plus cos theta. Now, looking at this, you have sine squared theta plus cos squared theta plus 2 sine theta cos theta. Isn't it similar to x squared plus y squared plus 2xy? It is. And what's that? How can I factor that? That is a perfect square trinomial. So if I factor that, that would be x plus y squared. So here my x is really sine theta, and my y is really cos theta. So this would be sine theta plus cos theta squared over sine theta plus cos theta. Now I have the same thing on both numerator and denominator. This can cancel out with that. So I'm just left with sine theta plus cos theta, which is same thing as I have on the right hand side. So left side equal to right side QED. Okay. So take a moment, pause the video, make sure you go through it, and make sure you understand how we did this question. Okay. Once you're ready, we move on to number 17. All right, so for number 17, again, same thing, you make your left side and right side. I already did that. Now you start work on one side or maybe both sides. Both sides have the same level of difficulty, essentially. It's made of the same stuff. So I'm gonna work on the left-hand side. Now, what I'm gonna do is I'm gonna try to write everything in terms of sine and cosine. So bring them into simplest form. So tan theta that's sine theta over cos theta multiplied by sine theta all over sine theta over cos theta plus sine theta. Now, at top, again, simplify further. Sine theta is really sine theta over 1, so I multiply them, I get sine squared theta over cos theta over, now in the denominator is an addition, so I find the common denominator. So this would be cos theta, and then this would be sine theta plus sine theta cos theta. Okay, so now what we can do is that, apologize for the sound, they're testing the PA system, so let's continue through this. All right, so we have at the top, we have sine squared theta over cos theta. Nothing I can do about that for now. By the denominator, I can factor out the sine theta, and that would be 1 plus cos theta all over cos theta. So what can I do now? What do you notice? That the cos thetas cancel out. So we are left with sine squared theta over sine theta times 1 plus cos theta. Now again, the square cancel out sine theta, so we are left with sine theta over 1 plus cos theta. So that's what I got on the left-hand side of my identity. And now I need to, it's not like what I have on the right-hand side, so I can work on the right-hand side and see what I would get if I simplify the right-hand side. So same approach, change the sign, tans to sine and coses. So it would be sine theta over cos theta minus sine theta over the sine theta over cos theta times sine theta. So again, find the common denominator in the numerator. That's cos theta, and that would be sine theta minus sine theta cos theta all over, and now it's the multiplication in the denominator, so it's sine squared theta over cos theta. Again, same thing, the cos thetas cancel out. You're left with sine theta minus sine theta cos theta over sine squared theta. So same thing as we did over there, sine theta is a common factor, we factor that out, we are left with 1 minus cos theta over sine squared theta. Again, similar approach, the sine theta and square cancel out. We are left with 1 minus cos theta over sine theta. Now let's compare what we have. So on the left side, I have sine theta over 1 plus cos theta, and on the right hand side, I have 1 minus cos theta over sine theta. Not quite the same. So does it mean we made a mistake? Does it mean this is not an identity? What does it mean? Well, it doesn't mean either of them. Means that we might need to do some more stuff before we can prove that this identity is actually correct. One thing we notice is that it's kind of a reciprocal of what I have on one side and the other side, and also in one I have 1 plus cos theta, in the other one I have 1 minus cos theta. So what I would suggest to do when I see something like that, that kind of talks to me about conjugates. Okay, remember in rationalization we talked about conjugate. So I'm gonna do that. So I'm on right hand side, so I'm gonna work on the right hand side. I'm going to multiply both numerator and denominator by the conjugate of my numerator, which is 1 plus cos theta. Oops. Over 1 plus cos theta. Now, because I'm multiplying by something over itself, I'm not really changing anything, because I'm really multiplying by 1, right? So when I multiply by conjugate, in the numerator, I have the situation with difference of squares. So when I expand that, I will get 1 minus cos squared theta. And in the denominator, I will have sine theta times 1 plus cos theta. Now 1 minus cos squared theta, what's that? Exactly, that's sine squared theta. So that will be sine squared theta over sine theta times 1 plus cos theta, which then sine theta cancel out the square, and I'm left with sine theta over 1 plus cos theta. And look at that, just like magic, my left side is equal to the right side. So left side equal to right side, QED. Alright. So, again, make sure you look through this work, make sure you completely understand it, and if you have further questions, you can ask me next day. Okay?